Hello out there to you. In this video, let's solve this problem. It's got a monopolistic competition or monopolistically competitive market. What that means is it's easy for new firms to enter or exit, and consumers do see some sort of quality difference between the products from one company to the next. So we got Janet. She produces this low-fat ice cream. Market is monopolistically competitive. We've been told that. So what this means, she can um, profit maximize. So down here, we're given this right here. This is demand. Okay. So we've got price and quantity. We could graph this if we wanted to. There's a couple ways to answer this question. These questions. You can graph everything. You could, this says here, you could calculate an algebraic expression for demand. So we could do that too. What I'm going to do is just calculate total revenue. And then I'm going to use total revenue to give me marginal revenue. And the reason I do that is because I'm going to produce ice cream up until the marginal revenue equals marginal cost, and that's known as profit maximizing. So we're told the marginal cost producing one scoop of ice cream is 40 cents. So I'm going to produce up until the marginal revenue equals 40 cents. Okay, so not too complicated. Let's do TR here, and then we'll do MR here. Okay, so the formula for total revenue is price times quantity, and marginal revenue, once you have that, is the change in total revenue divided by the change in quantity. So in this case, we're increasing quantity by 2, so it's going to be a change, we're going to divide by 2. Okay, so here we'll quickly calculate these guys. Because the problem we're trying to figure out, how many scoops of ice cream should she produce in the short run to maximize profits? So really that's just a different way of asking this question. So what is the quantity to get us there? Okay. Then we're going to calculate her profit in the short run. So we'll just calculate total revenue there minus total cost. And then what would price be the long run price and quantity if this was perfectly competitive? That one we can actually answer here. This is going to be where marginal cost equals price, because the consumer doesn't see any difference between one product to the next. So in this case, this would have to be 40 cents a scoop, because the marginal cost is 40 cents and they're going to produce up until the price equals marginal cost. So then it would be 40 cents would be the price, and then the quantity, we can just read the table. Quantity there is 8. Okay, so let's do the first part here. Let's do that in a different color. Okay, so total revenue here, price times quantity is 0. And hopefully I can do all this in my head. $3.20, $4.80, for also $4.80. This one, $3.20, and then this one doesn't make any sense. Giving it away for free, you'd make no revenue. Okay, so the marginal revenue is going to be the difference between this and this, but then divided by 2. So that's $1.60. Okay, and then the difference between this and this divided by 2. So that one is 80 cents, because it's 160 divided by 2. Okay, and then this one, this is no change. Okay, so it's actually going to be 0. There's nothing there. Now we've got total revenue declining, so it's a negative, and it's negative 0.8, or 80 cents rather. And then here it would be negative $1.60. Okay. Now you can do this a little more if you know calculus. You can algebraically find total revenue function, or this function here for demand, then take the derivative of that, but you don't need to in this specific problem. So now we just want to know what's the last unit we produce where marginal revenue is higher than marginal cost? So as long as marginal revenue is higher than marginal cost, we're going to produce it. So we're going to produce the first two. We're going to produce the next two. We're not going to produce that one. And that's because if in order to produce those two extra units, we have to drop the price, but we're not going to make any additional revenue to do that. So we're not going to do that. So the last unit where marginal revenue is higher than marginal cost is 4. So in this case, we're going to produce 4 units. And when we produce 4 units, we're going to charge a price with the associated demand, which is $1.20. Okay. Now her economic profits in the short run. So normally we just calculate total revenue, but we've already done that. So it'd be this would be $4.80 minus the cost. So it's 40 cents per scoop. So I'll go 0.4 times how many scoops are we doing? We're doing 4 scoops there. So that would be $1.60. Okay, so 480 minus $1.60 is $3.20, and so that's the answer for the profit. And we often use pi to denote profit. You can actually check this if you want. I'm not going to do that in this video, but you can check 320 minus 80 cents, and that'll give you your profit there. You can do 480 minus $2.40, see what the profit is. You can continue to do that, but you can just really just kind of trust me on that, and that's your profit maximizing formula. So this is how to do this monopolistically competitive problem.